atoms and their theories. Ancient Greek philosophers believed that matter was made out of 4 elements: earth, air, water, and fire, and that everything on earth was one of those 4 things with varying degrees of hotness, coldness, dryness, and wetness to mimic the different properties that they saw. Alchemists describe the properties of so many different materials. So their boiling points, their melting points. They did a lot of experimenting because they thought that they could change elements into gold. So they were working really hard with a bunch of different elements, heating it, cooling it, and doing a bunch of different things to try and do that or change them into gold. They used symbols to represent different substances. And to prevent others from finding out their secrets, because they wanted to be the first one to change things into gold and make some money that way. The current view of elements started with Sir Francis Bacon. He stated that all science should be based on experimental evidence rather than thought. Robert Boyle recognized that elements could combine to form compounds. So Bacon and Boyle both motivated others to search for elements. Others, after they saw this research, were more motivated to look at science. So scientists began using heating, burning, mixing, cooling, just like our alchemists did, to break matter down until it could not be broken down any further. And this was to determine if the substance was a pure substance or a mixture. They thought that if they could break something down as far as possible, they would know it was a pure substance. And if something could break down further, it was still a mixture. Antoine Lavoisier defined elements as pure substances that could not be broken down any further. He actually identified 23 pure substances as elements, which is a big deal back in the 1800s. And he was one of the first chemists to use a balanced view of chemical change. Again, the idea of a balanced chemical equation, but a very basic and primitive idea of that. So this is where they came up with the law of conservation of mass. So the law of conservation of mass says that in a chemical reaction, the total mass of the reactants is always equal to the total mass of the products. So matter cannot be created or destroyed. This is a really great little video explaining the law of conservation of mass, and I've linked it below our video here for you guys to take a look at. From this, they also created the law of definite composition. This states that compounds are pure substances that contain 2 or more elements that are combined together in fixed or definite proportions. This is the idea that in water, we always have 2 hydrogens per 1 oxygen. We don't have some water molecules where it's H3O4. This is no longer water. Water is defined as 2 hydrogens bonded with 1 oxygen. So there are fixed or definite proportions. Pure water always contains 11% hydrogen and 89% oxygen, which sounds funny because it's a 2-to-1 ratio, but this is by molar mass. So they, of course, couldn't see that we had 2 hydrogens per 1 oxygen. They could only measure the mass of things. So in the 1800s, scientists made the first battery using zinc, copper, and a salt solution. This is a big deal because, of course, they don't have electricity back then. They discovered that when they used this battery to pass an electric current through water, they produced hydrogen and oxygen gases. This is the process of electrolysis, using electricity to split molecules into elements. This was used to isolate different elements from compounds like magnesium, calcium, strontium, and barium. Okay, and again, they had this like fancy tube thing here, and it's full of water. And this is a closed end, this is a closed end, and this is open. Okay, it was all full of water to the exact same level at the beginning. So they connected their battery at the bottom. and they allowed electricity to go through the water. What they noticed was that the volume of hydrogen was twice as much as the volume of oxygen. And again, this makes sense because we have twice as much hydrogen as oxygen. So electrolysis was a really big deal. They started to isolate elements and understand these ratios, and they could put together some chemical formulas at that point. Dalton's atomic theory. John Dalton developed a theory that explained what happened in the electrolysis of water. He stated that 5 different things: that all matter is made up of tiny particles called atoms, that atoms cannot be created, destroyed, or divided into smaller particles. So we cannot create an atom from something smaller. They cannot be destroyed, and we can't divide those into smaller particles at that point. All atoms of the same element are identical in mass and size. There's no variation in them. Atoms of one element are different in mass and size from atoms of other elements, so we can differentiate them between their mass and size as well. Compounds are created when atoms of different elements link up in definite proportions. Again, those are the set ratios, like water is H2O every time. Dalton had an atomic model as well, very basic. He just says that atoms look like a solid sphere, or he compared it to a billiard ball. And so he could look at the size of the atom based on their diameter. So each element, again, had a different atomic weight. They have a different mass. They have a different size or diameter. And they all have very specific properties that define them. Dalton was onto something. So Dalton's law led to an accurate definition of elements and compounds. So elements are a pure substance made up of only one type of particle or atom, and each element had its own distinct properties, cannot be broken down into simpler substances by chemical change. Whereas a compound was a pure substance made up of 2 or more elements chemically combined together. Compounds can be broken down back into their elements by chemical means, and what they had discovered was electrolysis at this point. They can also heat, so they can decompose elements or compounds back into their elements. So laws, theories, and models, where do we get them? Typically, they start by an observation. We see something, we're like, that wasn't very well explained by what I know to be true in this world. So they make a hypothesis. They're like, but what if this is what's happening? Then scientists do experiments to see if they can prove that that would happen in all cases, that their hypothesis is true for all instances of that. If it is proven through experiments, they create a theory and they can test, and like it'll either be true or it is not. So if it is true, time and more experiments will continue to revise that theory. So it'll make it a little bit improved. If they get through these experiments, they're like, that didn't actually support my hypothesis. They would go back and make a new hypothesis, design some new experiments to test that hypothesis to explain our original observation, and hopefully get to a theory. So scientific ideas may change over time as evidence is gathered. Most of Dalton's atomic model has stood the test of time. However, smaller particles like protons, neutrons, electrons that we know make up an atom have been discovered since his first theory. Scientific models help others to visualize structures or processes that cannot be seen directly. So our theories help us to understand what is happening on a particle level, which is nearly impossible to see unless you have an electron microscope. So scientific models, again, help to give an explanation for what can be seen. And they often change over time. A really good example of this is the geocentric model, which is where Scientists thought that everything in our solar system orbited the Earth, including the sun and all of the other planets. However, with observations and data collection, experiments, they revised that theory to understand that we actually revolve the sun and the moon revolves around us. We're looking here, they had the moon revolving around Earth and the sun revolving around Earth. Rather than me explaining the rest of the atomic theories and including some diagrams, I thought that the crash course video did a much better job. And I love Hank Green. So please take a look at this video. Know that he talks a little bit fast, so pause it. Try and make some connections and understanding about each of the atomic theories he describes. There are also a summary of these theories in your textbook on page 113 if you'd prefer. Don't forget to complete your learning guide for atoms and their theories for this topic.